In this video, we'll set up a bunch of examples of solving problems using undetermined coefficients in a variety of contexts and seeing what we get for our general solutions. This first example, y double prime minus 2y prime plus 5y equals e to the 3t plus t. So as always, start with the homogeneous part, which has characteristic equation r squared minus 2r plus 5 equals 0. This needs a quadratic formula. R equals 2 plus or minus square root of b squared is 4 minus 4ac is minus 20 over 2. This will end up being 1 plus or minus 2i. That's a root minus 16 in that formula. So my general solution is going to be y of t is c1 e to the t cosine of 2t plus c2 e to the t sine of 2t. Now for the homogeneous part, I see an exponential and a polynomial as in a single t. So for that part, I want to guess a e to the 3t plus bt plus c. Since none of these functions solve the homogeneous problem, I should be fine. I need to guess the a to the 3t from the e to the 3t up here. And for the t, I need to guess the t and then everything stepping down to a constant term, so bt plus c. So this will be yp. The first derivative is going to be 3a e to the 3t plus b. Second derivative will just be 9a e to the 3t. And then we plug it into the equation. So I will get second derivative, which is 9a e to the 3t, minus 2 times the first derivative, 3a e to the 3t plus b, plus 5 times the function itself. And I want this to equal e to the 3t plus t. Let's collect some terms over here on the left. I see a 9, a to the 3t. I see minus 6 of those, so I'm at 3. Plus 5 gives me 8. So I am at 8a e to the 3t. For t terms, I have just the 1 over here. So it's just going to be plus 5bt. And for constant terms, I have a negative 2b over here and a 5c over here. So 5c minus 2b, I want to equal e to the 3t plus t. This means I want this coefficient to be 1, this coefficient to be 1, and this coefficient to be 0. What I get from that is that a should be 1/8, b should be 1/5, and then c, whatever it has to be to make that work out. So 5c minus 2/5 equals 0. So c is going to be 2 over 25. So that gives me a general solution as being y of t is my homogeneous part, c1 e to the t cosine of 2t plus c2 e to the t sine of 2t, and then my non-homogeneous part, so plus a 1/8 e to the 3t plus a 1/5 t plus a 2 over 25. So that is setting up the problem, using the equation to figure out the equation for the coefficients, and then solving that out to get the answer. For this example, we want to solve the problem y double prime plus 2r prime plus y equals e to the minus t. We can again start by looking at the homogeneous part. And for that, we see a characteristic equation of r squared plus 2r plus 1 equals 0. This is r plus 1 squared, repeated root. So my general solution here is y of t is c1 e to the minus t plus c2 t e to the minus t. Now for the non-homogeneous part, we would want to guess yp of t to just be e to the minus t, because that's what we see here on this side with the constant a in front. But there's a problem in that that's going to solve the homogeneous part because e to the minus t is right here. What do? Multiply by t. But we're still in trouble because that still solves the homogeneous part. So what do? Multiply another factor of t. And note that here, because I got to this t squared because things solve the homogeneous part, I don't have to include lower order terms, because if I do, they'll all just go to 0 because it solved the homogeneous equation. So we're going to start with this for yp, and then differentiate that and plug that in. So for this, the first derivative is going to be 2at e to the minus t, and minus an at squared e to the minus t. And the second derivative is going to be 2a e to the minus t, minus a 2at e to the minus t, minus a 2at e to the minus t. The second one is when the derivative hits the t squared here. The first one hits the e to the minus t here. And then plus an at squared e to the minus t. These two combine to give me a 4at to the minus t. And I can plug that in. So we have the second derivative plus twice the first derivative and plus the function itself. And we want this to match with e to the minus t. And if we look here, we will see that for the t squared e to the minus t, I have plus at squared. I have minus 2at squared and plus at squared. Those all cancel out. For the t e to the minus t, I have a 4 here, 4at e to the minus t, as well as a minus 4 here. Those will cancel out. And the reason they all go away is, again, because e to the minus t and t to the minus t solve the homogeneous problem. So all I'm left with here is a 2a e to the minus t equals e to the minus t, which means a is 1/2. And so my general solution is going to be y of t is c1 e to the minus t plus c2 t e to the minus t, and then plus my 1/2 t squared e to the minus t. There's an example there illustrating how you can repeat this process of multiplying by t when things solve the homogeneous problem, and you just want to keep going until they eventually stop solving that problem. If we'd stopped any step before that, we would have gotten to a problem where we couldn't actually get something that's to match up e to the minus t. If we go too far, we'll end up at matching with like a t to the minus t and not e to the minus t, and that's a problem as well. This is the idea of that process, how you can go through to pick the right guess and make sure you get to the right solution for these undetermined coefficient type problems.